Hello, ladies and gentlemen. So today we're going to be taking another look at evaluating these trig functions, but we're going to be using all of our previous knowledge. So we're going to be putting it all together. This includes our knowledge about reference triangles and reference angles, trig functions and those setups, your sine, cosine, tangent, cosecant, secant, and cotangent, having that unit circle chart handy. Okay, so making sure that that's available for us to use, and also remembering your special right triangle. So we made a foldable about that. So we're going to put all of this information together and see how this stuff sort of all comes together and meets here as we evaluate some trig functions for some different angles. So the best way to approach this is probably to do just 4 examples with you so you get the hang of how the thinking goes and how we walk through a few of these. And then, of course, you'll have time to practice a few on your own. So let's do four examples here. Make sure you write each and every one of them into your notes. They're all different. The setup's a little different. So each and every one has something valuable to offer to your discussion and your understanding. So we're going to find the exact value of the trig function. This means that we are not going to just type this into our calculator and place a decimal answer in the blank. We need to be able to develop what this exact value is. So to do this one, it says we're going to do the cosine of negative 225 degrees. Before you start, you need to draw a picture of that negative 225 degree angle. That's what it's all about, okay? So we're going to sketch in. I'm just going to do a quick sketch here. It doesn't have to be completely 100% accurate, but we're going to try to get that sketching business down. And we're going to draw that negative 225 degrees. Okay, so remember with me when we draw these angles, we're going to start with our initial side on the x-axis here, and then we're going to go ahead and go negative degrees. That means we're going down this direction. This would be negative 90, negative 180, and if I go all the way up again, it becomes negative 270. So what I need to do here is draw my angle somewhere in between those two. So this is negative 225 degrees. Now when we draw that, that becomes a nice angle for us, but remember this is about reference triangles. We need a triangle to set up this cosine. And so we need to remember how to draw that reference triangle in here. I'm going to erase these little dots in here so I have some room to write. And I'm going to drop that line straight down from my terminal side to the x-axis. So this is the x-axis here, okay? And we drop that straight down. I've created a reference triangle again. And in that reference triangle, we always want to make sure we can identify our reference angle located right here. So that reference angle, we want to know those degrees. We want to be able to figure out those degrees right there. So remember we went negative 225 degrees. So we went past 180 right here. How many degrees past 180 did we go? Okay, you should be thinking, how many past 180? So that's 225 minus 180, 45 degrees. That means this angle right here is 45 degrees. That reference angle is 45 degrees, which means what we're looking at, guys, is a 45, 45, 90 triangle. I know this other angle up here also has to be 45. It's a 45, 45, 90 degree triangle. And now from that understanding, we should now be able to remember our lovely special right triangle rules. Now remember in your special right triangle rules, the hypotenuse was the square root of 2 times the leg. So the leg times the square root of 2. Now what would be the easiest for us is if we called this leg 1 and we wrote the number 1 there. And we called the other leg 1. Because if I take 1 times the square root of 2 to find the hypotenuse, that would just be square root of 2. Now I'm going to do a little adjustment here because remember this triangle is on a graph. And really if I go over this direction 1, I went over negative 1. So I need to be sure that I label this side of my triangle negative 1 because that indicates the direction here that my triangle, or actually the location of my triangle on this side of the coordinate plane. Okay, so negative 1 over, and then up, that should stay positive 1 there on the green line. But my square root of 2 is there because that comes from my special right triangle understanding. That if my leg is 1 and the other one's 1, then my hypotenuse then becomes 1 times the square root of 2. So that negative I put on there just because of the location. Now once we have our triangle set up, and remember, this is the reference angle we're talking about, so this is the one we're standing at, we now want to set up the cosine. Cosine is adjacent over hypotenuse. So if we are here, what's the adjacent side? Well, that's -1. And what's the hypotenuse? Well, that's the square root of 2. So I now look at my answer and I'm kind of liking it, except that it has a square root, a radical in the denominator, so I need to take care of that. Rationalize the denominator, multiply by the square root of 2 on both top and bottom, and you get negative square root of 2 over 2. So -1 square root of 2 over 2. Lovely. This is the exact value of the cosine of -225 degrees. Now, if you were going to type in your calculator cosine of -225, which you could do, but of course it's going to give you that icky decimal value. But then if you also typed this one in, guess what? They're the same, okay? So that decimal value you get from your calculator, this is the exact value that we're finding when we draw these reference triangles. All right, let's take another look at a couple more examples. Here we have the secant of 300 degrees. So the first thing we're going to do is sketch the picture, x, y, and we're going to go ahead and sketch our 300 degrees. The initial side, going 300 means I'm going this direction. There's 90, there's 180, there's 270, and a little bit more. So there's my 300 degree angle from there to there. Now I need a reference triangle. So we always, terminal side, x-axis, that's how our reference triangle is formed. And now we need to figure out our reference angle in the corner there. So remember we went 300 degrees this way, and we want to know how many degrees are right in there. So if we do the math, 300 degrees are used up out of a full rotation. So I've used 300 degrees out of that full rotation. That leaves me with 60 degrees right there. So that is a 60-degree angle. That is the theta. That is the reference angle that we're standing at, okay? Now from there, we're going to use our knowledge about special right triangles, because you know what? This is a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, remember, we have two facts. We have the fact that the long leg equals the short times the square root of 3. And we also have the fact that hypotenuse equals 2 times the short. Now notice that the short in here is listed twice. That's really the thing that we want to know, or the thing that we want to find. So it would be to our benefit to call that short leg 1. So we're going to call that short leg 1. Where's the short leg on our picture? It's always across from the 30 degrees. So this is the short leg, and we'll call that 1. And from there, we're going to generate the other sides. So the long leg would be across from the 60-degree angle over here. The long leg is the short times the square root of 3. So 1 times the square root of 3 just leaves me with the square root of 3. And the hypotenuse of my triangle is 2 times the short. So 2 times the short leg, 2 times 1 would be 2. So I've placed my values on there, and now we need to make some adjustments based on the location of this triangle. So is the 1 okay? Well, yes, I'm still over +1. Is the square root of 3 okay? No, not so much, because this is actually down -3. So we need to make sure that we have a -3 right there, negative square root of 3. And then my hypotenuse can stay at 2. So once my triangle is drawn, and now we want to do the secant. Now, if you remember who's related to the secant, that is the cosine. It's the reciprocal of the cosine. So remember that cosine is adjacent over hypotenuse, but now we're going to do hypotenuse over adjacent because we're talking about the secant. So standing there at that reference angle, we're going to do hypotenuse over adjacent. So hypotenuse in our case is 2. And then we're going to go ahead and do the adjacent side, which is 1. So my secant of 300 degrees simplifies to 2. Okay, so that's what we're doing each and every time. Drawing a picture, using our knowledge, and kind of putting it all together. Here's number 3. Now this one has a pi in it. So if you're thinking what I'm thinking, and I hope you are, this one is in radians. So we're going to need to do a little converting ahead of time to convert this guy into degrees to do some more understanding of what's happening. So let's go ahead and do our conversion. We have degrees over 360 equals my radians over 2 pi. And we talked about simplifying these pi's. There we go. So if we cross multiply, we get 2x. And if we take 360 times negative 8/3, we get negative 960. And then if we divide that by 2, negative 960 divided by 2 is negative 480 degrees. So this is what we're talking about. This is negative 480 degrees. So to do this, we're going to do the same thing we were doing before. Draw the sketch, find that triangle, place our values on it, and set up the ratio. Okay, so here's my x and y axes. We need to draw negative 480. So starting with my initial side, going negative 90, negative 180, negative 270. Oh, that's negative 360. Okay, where else am I going? Negative 360 and 90 more, 360 and 90 more would make 450, but I need to go 480. So right here, sounds good. Okay, so we now need to figure out what in the world. Remember, we were at, this one right here was 450. So I went a little bit farther. I went 30 degrees past here to get to this spot. That's 450. Let me adjust that. There we go. And we went 30 degrees past. Now we have our terminal side drawn where he needs to be. And we're going to go ahead and drop our triangle in there. Okay, make sure our triangle's showing up. And now we can go ahead and find our reference angle. Now remember, we went 30 degrees past this 90 here. So that means that I have 60 degrees left inside my triangle. 60 and 30 makes the 90 degrees that we're looking at for that quadrant. So 60 degrees, again, we're looking at a 30, 60, 90. So I'm going to go ahead and place the 30 where he belongs. And remember our ratios for 30, 60, 90. Remember our setups. Remember our understanding of those side lengths. We want the short side, the short leg to be 1. We want the long leg to be the square root of 3. And we want the hypotenuse to be 2. Based on our facts about 30, 60, 90 triangles. Now let's do some adjustments based on the location. This is actually over -1 on a coordinate plane, and this would be down negative square root of 3 on the coordinate plane. So now when we want to set up the cotangent, ladies and gentlemen, now that we have our triangle fully labeled, we're at that reference angle. Our cotangent is the reciprocal of the tangent. Tangent is opposite over adjacent. So we're going to do adjacent over opposite. So -1 over negative square root of 3. Now, two negatives, you're thinking, that's 1 over the square root of 3. You can't leave the square root of 3, so we have to rationalize the denominator, and we end up with square root of 3 over 3. So that is the exact value of the trig function described there. Okay, and I'll do one more example with you. This is the tangent of negative 3 pi over 4. Okay, tangent of negative 3 pi over 4. So again, we're going to make sure that we can calculate those degrees. So degrees over 360 equals radian amount over 2 pi. So we're going to go ahead and cross multiply. 2x, 360 times 3/4 is 270. So we have negative 270. And then we're going to go ahead and divide by 2. So x equals, divide by 2, 135 degrees. And we have a negative there, so negative 135. So again, we're going to sketch our triangle now that we know how many degrees these radians represent. So negative 135 degrees. We're going to go ahead and calculate or figure out exactly where that goes. So we're going to place our initial side. And now negative means we go down 90. Oh, not to 180, so we'll stop right there. That is my negative 135 degrees. And then we make our reference triangle. Terminal side straight to the x-axis. And now we need to figure out our reference angle. So remember, we went negative 135 degrees, so we went 135 degrees in this direction. 135 degrees in that direction. That leaves me with, out of 180, a 45-degree angle right here, a 45-degree angle right here, because we're looking at a 45, 45, 90. So let's place our values on one more time. 45, 45, 90. We want those legs to be 1. 1, 1, and then my hypotenuse is the square root of 2. So let's adjust based on the locations. So we went over negative, we went down negative, there we go. And now we can go ahead and set up the tangent. Tangent is opposite over adjacent. So opposite at 45 reference angle would be -1, and adjacent to the reference angle would be another -1. -1 divided by -1 is 1. So I end up with 1 being the exact value of that trig function. Okay, so this is a process we do each and every time. I want to make sure to thank you for taking good notes. See ya!